and welcome everyone. This is amazing. This is the last talk before the keynote, and then we can all go for a beer. So that's great. Woo! Yes, absolutely. Thank you for being here. Hello to all our home viewers. Look, last year I was at this conference, and I spoke about serverless architectures and technologies, and why I think, that this is the future of software architecture. And over the past 12 months, I've had a few additional thoughts and realizations that I want to share with you in this presentation. So this is me. I work for a company called A Cloud Guru. I started as VP of engineering, but now I look after the content, after the courses that we produce. I've written a book called Serverless Architectures on AWS, and it's been translated to Japanese, and it's a beautiful book. I obviously cannot read it because I don't read Japanese, but people tell me that it looks correct, which is excellent. I helped to organize a conference called ServerlessConf, and I have also recently been made an AWS community hero, which is a big honor and very, very humbling. So yeah, as I said, this is the company that I work for, A Cloud Guru, and our focus, our mission is to produce great courses, great content, and help to upskill people on cloud computing. And an interesting thing about our company is that we are entirely serverless, right? So we built our platform serverless from the very start. And we've grown to be quite large. We have 500,000 students who use our platform, who take our courses, and that's kind of incredible. And we've been in love with this whole idea of serverless from the very start. So we developed a few courses, we organized our conference, and we ran it in New York and Austin, Texas, and London and Tokyo. And the next one is actually coming up in San Francisco at the end of July, start of August. So if anybody can make it, please come along. And yeah, so we've been really into it. And look, I'm not going to go into what is serverless. I mean, you've had a bunch of talks today already. But I just wanted to highlight kind of the comparison between what serverless is to PaaS, to infrastructure as a service. I mean, really, to me, serverless is all about function execution, right? Cloud, scalable function execution. It's about using managed services. And it's about using certain patterns and architectures in concert to produce scalable, event-driven, reliable systems. So let's take a look at our platform. As I said, it's entirely serverless, and this is what we have. So I went into the AWS console, and I had a look at the stats for the month of February. So you can see we've made nearly 50 million Lambda invocations in that month. We had 27 million API requests put through the API gateway in that month as well. And we've transferred something like 37 terabytes of data in February. So, seeing this, 50 million invocations of Lambda, so many millions of API requests through the API gateway, and this much bandwidth. Can anybody guess what our bill was for AWS for this month? Any guesses? Yes? 1,500, that's a good guess. Any other guesses? Under 200. I wish it was, okay, that's lovely, but no, it's a little bit higher than that. Any other guesses? Yeah. 1,501. I'll take any offers. That's right, I won't torture you anymore. So this was our bill for the month of Feb. And so you have to remember that, we have, tens of thousands of users. This is a very busy system. It's available. We have users from 135 countries around the world, and yeah, it's very busy. So kind of a few interesting things here when you look at this table. CloudFront accounts for more than half of our cost. Obviously, our bandwidth is enormous. We send a lot of data, so that's that. Something that was counterintuitive to me is the API gateway pricing. I kind of thought that API gateway should be expensive, right? I don't know, I just always thought, but it was only $100. Lambda was only $206 for 50 million invocations, which is kind of incredible. So when you look at this bill, it's like, wow, going serverless purely from an economic perspective makes sense for our system, right? It's been incredible. The other thing that I should mention is agility. I just Googled agility and clicked on image search, and this is the image that came up. So that's why I'm using it. Serverless has enabled our team to be really agile. Now, we can actually add new features and quickly kind of solve our business problem with this approach. We don't have to worry about infrastructure. We don't need to worry about provisioning servers, managing containers. We can focus primarily on our business. And that has been incredible. And that has really propelled our growth and got us to where we are. And I don't think we could have done it any other way. So this has been really, really good for us. So this is kind of a vastly simplified overview of our system from an architectural perspective. So we have an SPA, a single-page application that's a mix of React and Angular. We have an API gateway that connects to a Lambda function, which hosts our GraphQL endpoint. And that GraphQL endpoint can talk to a bunch of other microservices, right? So you can see microservice A, which is fronted by another Lambda function, microservice B, which is fronted by an API gateway, and we're kind of moving to that approach where every microservice is fronted by an API gateway. And using schema stitching, we can kind of send our requests off to DynamoDB, grab some data, return it back. Sometimes when we make an update to DynamoDB, that invokes a function as well, which then goes and updates Firebase. And Firebase is basically, it's a database produced by Google, and we use it to kind of have a materialized view for our website. It's the materialized kind of interface that our website has. We also update things like Algolia, which allows us to do searching. And then we have CloudFront and S3. So these are our videos, our terabytes and terabytes of video. Our CI/CD pipeline, nothing too fancy. I think you would all be familiar with something like this. We have GitHub, which when we need to deploy, it kicks off a Travis CI job. We run a bunch of tests using Cypress and Jester, and then we go off and we deploy things to AWS. So when maybe we deploy a bunch of new Lambda functions. We deploy our single-page application to Netlify. So we don't run it from an S3 bucket. We use Netlify instead. And then perhaps we update other services like Firebase and Algolia. We use Serverless Framework. It's a great tool. And we use Ansible sometimes to spin up some infrastructure in AWS if we need it for our developers. So I kind of want to share some stories and some learnings with you. And look, I hope you find them interesting. I would love some feedback from you, whether you think these are useful or not. So Frontend Failover. Kind of, we pride ourselves on being available all of the time, right? We have 500,000 users, 135 countries. We need to be always available. There's always somebody on the platform watching videos or interacting in our forums. And then back in December, Netlify went down. So people would go to our website and they couldn't load the site, right? And we kind of just sat there going, uh-oh, this isn't good. So for 48 minutes, nobody could access our website. So what do we do? So I had a thought, maybe we could do something in terms of failover. Luckily, Route 53 has this awesome feature called the health check. And what it does, it allows you to basically ping a particular endpoint. And then if that endpoint fails and returns a different status code to what you expect, you can change your DNS to point to a different endpoint, to point to a different record set. So effectively, you can point to Netlify, and then if Netlify goes down, you can quickly, without any user kind of manual intervention, you can quickly update your DNS to point to an S3 bucket with your website instead. So I thought, OK, I'm going to do a little experiment. So I set up, I registered a domain called serverlessarchitectures.com. This is Netlify. I kind of deployed my code, my SPA there. Then I deployed exactly the same files to an S3 bucket, right? So two systems, entirely separate, same files, and awesome. So then I went into Route 53, and I created a health check, which I called H5 boilerplate. I don't know why. It's a very intuitive name, as you can see. And I configured that health check to look at this URL that I have there, which is just index.html, basically, of my website. I've configured a request interval of 10 seconds, and this is all configurable. You can change it. It's all up to you. And a failure threshold of 3. So in other words, if you get 3 errors, then switch DNS. The other thing is the health checker regions. So you can perform these kind of health checks from different regions around the world, which is very useful. Cool. I configured the first record set. This is the one that points to Netlify. And then I configured the second record set, which points to S3. And you can see there's a routing policy that you specify. It's called failover, and you can say that this is a primary record set, and then this is the secondary one. That's it. It's like it literally takes 30 seconds to do this. Awesome. I was actually going to get like a teammate to do this for me instead, but I didn't get time to do it. So yeah, there's a smiley face. Yeah, so I went to the website, opened it in Chrome, or is this Safari? I don't know. Hit the website, here's the response. It comes from Netlify. That's great. Then I went to Netlify, and I found this big, dangerous button called delete this website, delete this site. I clicked the button, and the site was gone. So health check luckily picked it up and started saying that, look, your site looks unhealthy, which it really was, because it was deleted. And it automatically updated our DNS to point to S3. So I basically refreshed the website, and there it was. So look, something to think about if you're worried about failover and how things may work. You know, is my site going to be up? Route 53 has this awesome feature that I think not a lot of people know about. All right, awesome. But then what about APIs? So let's say you have your beautiful serverless architecture with Lambdas and API gateways and everything else, and something happens. Can you do the same thing there? Well, yes, you can. So a little disclaimer. This is a hugely simplified example, right? It's kind of trivial. If you add things like caching, if you add messaging, obviously the story becomes a lot more complex. But I just wanted to illustrate a couple of things for you here. I have two identical systems, right? One is deployed into US East 1. The other one is deployed into US East 2. Same API gateway, same Lambda functions. I am, however, using DynamoDB global tables. DynamoDB global tables, it's an excellent new feature which was announced by AWS back in reInvent last year. It basically synchronizes and replicates your data across multiple regions automatically. So you write to DynamoDB, and then your data is replicated, which is kind of fantastic. You don't need to do any of that work yourself. So here we have two systems which are identical, and we have a health check as well. And that health check can ping the first API gateway and then switch to the other region if it needs to. When you create an API gateway, you have two options. You can create an edge-optimized API gateway, which is kind of the default option, or you can create what's called a regional endpoint. So in this case, you create effectively two regional endpoints. One is in US East 1, the other one is in US West 1. By the way, this all works with SSL, so there's no problem there. So we have two separate API gateways, Lambda functions, and the systems are identical. Same thing here. We have a health check that basically pings some kind of URI or URL and expects a particular response. So here I'm kind of looking at the response. It's coming from Virginia, so it's coming from US East 1. Then I just jumped into the API gateway and changed one of the settings. So now I require authorization. which means that I'll get back a 403 instead of a 200 response code, right? And this is what happens. So the health check goes, uh-oh, something has happened. I'm getting the wrong status code, which I didn't expect. And then, luckily, it automatically switches to the other API, right? So our system continues to function. So it's very powerful. Have a think about whether you can use this technique, whether you can use this approach, because I think there's something there, and not a lot of people are really aware that this is possible. And again, yes, I do understand that for more complex systems, the story is trickier. If you saw my talk from last year, I was kind of sharing some of the architectures that we've built internally at A Cloud Guru, right? And one of the architectures is this Transcoding Pipeline. And basically what it does, it allows our instructors to upload videos to our platform directly from their browser, right? So they can upload videos straight to an S3 bucket. That kicks off a Lambda function, right? This whole architecture is event-driven. So that kicks off a Lambda function. Lambda function kicks off an Elastic Transcoder job, which creates different versions of our video files. So transcodes our files to like a 1080p version, 720p, 480p, HLS, WebM. Then those files are placed into another S3 bucket that kicks off, that pushes a message to an SNS topic, which sends out to a bunch of other Lambda functions that then go and update the database and do other various things. Again, this is hugely simplified, but I just wanted to show you how a part of our system functions, right? It's all event-driven. It's all automated. The one tricky thing there, though, was what happens if a Lambda function fails, right? Because things fail all the time. And so we had a bunch of kind of code that would kind of detect an error and try to handle that error. Luckily, now there is support for dead letter queues. So if a function does fail, you can tell that function to place that particular event or message that it is trying to process into an SNS topic, right? A different SNS topic. And then you can hang another Lambda function of that SNS topic. And that Lambda function can address the issue. So it can pick up the message and say, OK, maybe I will requeue this message again. Maybe I'll try to process it some other way. Maybe I will just notify the developer to say, look, something has failed and you need to have a look at it. So this is, I don't know, I thought this was a pretty powerful technique that people should be aware of, using dead letter queues when things fail. And by the way, this only works for asynchronous invocations of Lambda. It doesn't work for synchronous invocations. So synchronous invocations are, for example, when you invoke a Lambda function yourself using the API gateway. This only works if you invoke a Lambda function through an event that happens in one of the other services, like an S3 bucket or an SNS topic. So please be aware of dead letter queues. Another interesting thing is kind of burning down the house, right? So let's say you have an old relational database, and you're using Lambda to, write things to it. If you're not careful, you can do bad things, right? You can saturate your database connection pool and then make everything unresponsive. So luckily, now we have concurrency controls. So you can say that, this function should have a maximum capacity of 200, right? So you cannot just saturate your whole database connection pool if your function talks to a database. I think this is just a little bit clunky at the moment because you may have multiple functions. These functions may have different usage profiles. Some may talk to a database a lot. Some may talk, not as much. There are various kind of approaches for dealing with this. So this is kind of an example produced by somebody from AWS. Here you have like another Lambda function that basically tells you whether you can or cannot open a connection to a database because your connection pool may be exhausted. So I think this just shows us that it's everything like serverless is getting more advanced, but there are still some cases that require work. However, if you do use DynamoDB, then you're fine. If you use serverless Aurora, then you're fine. It's really only kind of for the more legacy relational databases that you have to be aware of this. Some tips. I think most of you should be aware of these tips. Obviously, one function equals one task, so avoid having very fat monoliths. Don't, create, a big fat monolith with lots of logic in a single Lambda function. No state. So statelessness is the magic sauce. It's the glue. It's what actually makes Lambda so scalable and so powerful. Design for failure. Things will fail, like I said before. Set function concurrency to 0 as a kill switch. So if your function is doing something crazy, it's going out of control. There's a thing called serverless cancer, right? I think Rob Grul from Nordstrom coined that term. It's basically, it happens when your function keeps instantiating again and again, and it's just spreading. So here's an example, and I've done this myself. Let's say you put a file into an S3 bucket, and you configure that S3 bucket to invoke your Lambda function, right? Then that Lambda function, I don't know, maybe it writes back another file into the same S3 bucket, which invokes another function, and it just keeps going in circles. What if you write 2 files back into that S3 bucket? That would invoke 2 more functions, and it would just spiral out of control. So you can set function concurrency to 0 as a kill switch if something goes wrong. Incremental architecture. I think it's not a dirty thing. I think if you're looking to start with serverless, just start building something. You don't need to, have it perfect from day one. Just build it, refine it, understand how it works. That would be my approach to take if I was starting off today. I'm currently working on a book with Tim Wagner and Yochai Kiryati on patterns and architectures, because we realized that one thing that's preventing adoption of serverless architectures is lack of patterns, right? How do you actually build scalable, reliable things? It's hard, right? There's the original Gang of Four patterns book, which is amazing. It's brilliant. It's 20 years old, but it's our reference. But we want to kind of write something for this generation, and for people who are looking to get into serverless. So we started looking at various patterns and how do they work in this new, interesting serverless world. Is there anything that's different? Should we be thinking of different things? And it's interesting when you kind of dig deep into these patterns, you realize that they can actually be quite complex. You have Fanout. We kind of know what it is, right? But then you start considering synchronous Fanout versus asynchronous Fanout. Then you start thinking, what about, I don't know, transactional Fanout? How would that work? Does it work at all? Interesting questions. I guess in the 10 or so minutes that I have left, I wanted to run through a few interesting patterns that I have personally found useful, and I hope you will find useful too. The first one is actually my favorite one. It's the API proxy pattern. And it's such a great little pattern when you have 2 systems that cannot talk to one another. So let's say you have a system A, which is a JSON-based system, and it talks and understands JSON. And then you have system B, which is an XML system, and they're not compatible, but they need to talk to one another. So one way to address this problem is obviously to begin modifying both systems, to couple them together. They can now talk to one another. Is there a good way? Perhaps not. An alternative approach is to have an API gateway, is to have a simple transformation function, which takes a request from one of the systems, transforms it to kind of to a request that the other system can understand, and basically mediates between these 2 systems. And I've seen this done in production to a very, very effective degree. So if you do need to have 2 systems talking to one another, consider doing something like this. It's very quick, very easy. Simple Fanout, again, it's allowing multiple endpoints to receive a copy of an input event. I think a lot of us have seen it before. So you could implement it in a few different ways. You could have a Lambda function just asynchronously invoke other functions. A better way to do it is to use something like SNS, which will fan out and invoke other Lambda functions for you. This is a good one, inline stream transform. So you can transmit data between systems, right? You can use a stream to do it. And you can create a transformation function which will basically transform your data as it comes into the stream. So here's what I mean. So you may have producer A that pushes data onto a stream. You can have a transformation function that kind of just sits on top of it and transforms data, transforms whatever is pushed onto the stream. Then it places that particular, I don't know, bit of data back onto the stream to be consumed by some other consumers. So if you use Kinesis Firehouse, for example, this is a feature that's supported, right? So you don't need to have two separate streams. You just have one stream with a transformation function which sits on top. I mean, yeah, you could build it yourself with two separate streams. That's completely fine. You can do it. But Kinesis Firehouse actually supports having kind of a function that sits on top and transforms data as it comes in. So it's incredibly, incredibly powerful. So yeah, please check it out if you are kind of doing this kind of work. I've been getting signs that I should probably wrap up very soon. I guess, how do you get started? This is a very interesting event-driven serverless world. It's growing bigger by the day. We can feel it. We talk to a lot of people who are building systems with serverless architectures, who are creating Lambda functions, who are building API gateways, and just doing amazing things. Please check out /CloudGuru /serverless. We have a lot of good stuff there that you can have a look at. There's this book that I mentioned before. It's probably pretty good. I don't know. So I'm actually working on a second edition right now. Please follow /CloudGuru, and myself. We typically like to tweet a lot about serverless things. That's it from me. I hope that wasn't too quick. I know that the slides and the video will be available, so you can always go back and review. But if you have any questions, please let me know. Please ask, tweet, email. I'd love to chat to you if you have any questions or comments.
So Peter, you actually have plenty of time left if you want to keep talking.
No, it's fine. I can take questions.
So we have a few questions.
Yep.
When the Wi-Fi is ready. So any questions from the audience while the website is loading? Okay.
There's a few.
Yep. Actually, we're going to start over here, and I'll come back to you.
So when you're using serverless, is there a way to avoid vendor locking?
Yeah, it's an interesting question about vendor locking. It's actually funny. I don't think that you're probably thinking of vendor locking in terms of Lambda, right? I'm going to use Lambda and I'll be locked into AWS. I think vendor locking actually happens when you use all the other services, right? It's when you use S3 or DynamoDB. It's the other. With Lambda, because it is just your code, you can pick it up, you can wrap it, and you can, transform it. You can push it across to Azure or GCP. It can be done. And kind of the recommended approach to building Lambda functions is that you write your code as a library, basically, and then you can just invoke it from a Lambda function, right? So Lambda becomes just a thin layer. So I don't think that the issue really is moving functions from one vendor to another. It's more about the other services that you might be using within your serverless architecture. Now those, yeah, that's a good question there. You need to really assess and see if another vendor that you're moving to has similar services, if they do a similar thing. Yeah.
Okay, thank you.
Yeah.
So we had a question in the back.
You already touched on a little bit with the RDS and Lambda being, especially with the legacy databases. I was just going to ask if you had any kind of war stories about large connection pools, and you kind of went over with one slide, but just any feedback or insight you had.
Yeah, great question. So Look, I don't have any war stories myself because we use DynamoDB and we use it from the very start. So there's, but it is an issue, and I know people have faced it. So that's why I wanted to kind of highlight for people who are considering using relational databases with serverless, well, with functions, that you need to be aware of this particular issue. If you do use DynamoDB, if you use serverless Aurora, then yeah, you don't have that same issue. It's a lot easier. Absolutely.
Okay, so the website has loaded. So from the app, we have a lot of questions, and so we'll start with this one. What are the things you wish the Lambda ecosystem had?
Wow, what are the things I wish the Lambda Great question. Look, I wish Lambda ran for longer than 5 minutes, for example. That would be great. Yeah, who's with me? Yeah, there are people with me. Excellent. Yeah, so that would be great. You know, it's kind of a simple thing that could do a lot for us. You know, more languages would be great. There are certain languages that I would love to see that are not supported at the moment. We finally got Go. Go is now supported with Lambda, which is excellent. So thank you to the serverless team. I don't know, I think I have a whole list of features that I would love to see happen, and I'm sure that the serverless, that the AWS team is working on it now. Do you guys want to see any features? Is there anything in particular that you think Lambda needs? This will go on video, so the serverless team can watch this and implement those features. Fix cold starts. Server sent events. WebSockets maybe, yeah. 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 Yeah, we've got a list here. I actually don't think that cold starts are such a big issue. No. Yeah, I mean, it's fixable, yeah. I mean, if you are experiencing cold starts, there are ways to kind of optimize for that. You know, you can invoke functions on a schedule, like on a scheduler, to keep them warm. I know it's not ideal, but there are ways around it. For our platform, at least, it's actually, we don't see that problem because I think our Lambdas get hit so often, they never get to go cold and stale. So they're always warmed up. But yeah, for the people who do experience this problem, yeah, I think there are ways we can kind of work around and try to solve them. So WebSockets, server sent events, any other requests? SQS triggers, I heard that it's coming. Yeah, team, if you're watching this, please, SQS triggers. I think we had a question at the back. Yes, yeah. Payload limits, even when you invoke a Lambda function, right, via SNS, let's say, the payload, the event that you can send from SNS to Lambda is only 128 kilobytes. So, you know, it would be good to increase that. So yeah, I think there are a lot of features, so I'm sure that the team at AWS is busy implementing a lot of them. Faster API gateway deletes. It's an interesting one. How often do you delete your API gateways? It's okay. Yeah. So excellent. So Brian is requesting faster API gateway deletes. Thank you.
Okay, so back to the app. We have more questions. So let's go with any thought on how to integrate with a legacy system like a mainframe in traditional infrastructure from a serverless system?
Yeah, so integration with legacy systems. So what I'm seeing at the moment is that people kind of gradually introduce Lambdas or serverless techniques into their legacy systems. And what they do is that they find a feature that needs to be implemented something small. They perhaps implement it with 1 or 2 Lambdas, right? Just to get some experience, to get some confidence that this works. They see how resilient and robust and scalable it is. And as they build kind of confidence, they begin implementing more and more features with a serverless approach, right? So they add more Lambdas, or they begin to add other managed services into the mix. And finally, you can get this interesting kind of, I wouldn't call it a monster, but it's a hybrid, right? So you have your legacy system with some serverless components. And that's actually not a bad thing, because your application may actually work better. At least some of its components will be more scalable than before. Yeah, I think that's the best way, that's the best kind of recommendation that I can give. Just gradually implement little features little by little and make them serverless.
So the next question is, how does a Cloud Guru use API gateway caching?
Caching. How does, well, we have caching enabled. I cannot give you like a very, very detailed technical response. But you can come and talk to me later. We can investigate it together. Who asked that question? Perfect. Let's chat after.
So the next one is, what tools are you using to provision and automate the deployment process? Have you suffered from DDoS attacks? How does AWS Lambda react to that?
Yeah, no, good question. So we use serverless framework for provisioning and deployment of our entire serverless architecture. Well, serverless framework and CloudFormation, I should say. So we use both of them in concert. No, we haven't been DOSed. Please, no one do it. Please. Obviously, no, especially the two people in the front row. It's obviously, API gateway has some protections against DDoS attacks, and it will basically start kind of limiting API requests if that were to happen, right? So you get a 429 response code if you begin abusing your API gateway. So look, obviously DOS attacks happen and they're hard to defend against. But luckily, we've been able to cope. Our system has scaled to all of the demand that we've needed so far.
2 more questions, and then we'll go. Yeah, we'll go to you.
Yeah.
Actually, Brian, if you want to go ahead and ask your question, go for it.
This is GOTO Chicago, and the question was, are containers still useful? I feel like I need to be very careful when I answer this question, especially given that it's recorded and on camera, and I may not be invited back next year. Containers are very useful. No, of course containers are useful. I mean, of course. I mean, containers are the enabling technology for serverless, right? That's how functions work. Actually, one of the previous speakers used this same line. They are the enabling technology. When your Lambda function runs, it's basically a container that spins up, executes your code. So yeah, it's absolutely necessary. Would I want to actually run my own containers, orchestrate them? Maybe not, unless I had to. I have seen systems which are a mix, a hybrid of containers and serverless. And it's kind of used in cases where serverless just doesn't work, right? So let's say we have to do something and it takes longer than 5 minutes. And we cannot decompose and parallelize a task, right? We cannot use MapReduce. So yeah, maybe your function should then spin up a container, execute a job that you want to happen, that you need to happen, and then kill off the container. I've seen a company trying to do 3D rendering in Lambda. That's hard, right? That's a very hard task. And they were asking me, how do we divide the job so we can, fan out to 1,000 lambdas and do that 3D scene rendering? And maybe it's not possible. I don't know. So yeah, so I think there are of course still use cases where you have to have something running longer than 5 minutes. Of course. So yes, we love containers. Yeah.
So the next question is, when AWS launches new services, how does a Cloud Guru go about learning it, then creating content to teach it? Any processes?
Yeah, I mean, look, this is something that we do day in and day out, right? So we are in the business of education, and we have to stay up to date with all the new events, changes, happenings that happen within AWS and everywhere else. So absolutely, we stay, our instructors, and you can talk to them directly later, but they read blogs, they perform a lot of experiments, they build things themselves, they make things open source, they talk to the community, they do a lot of things. We do this show called AWS This Week, and we do it every week, where we try to summarize in 5 minutes all the changes that have happened to AWS in that week. And it's insane because we always have content every week. Like it's amazing. It never stops, right? So every week we're like, all right, what are we going to talk about? And there's this list of all the changes, additions. It's incredible. So yeah, I guess, look, my advice, stay engaged with the community, follow websites like A Cloud Guru, talk to the community, read updates, look at blogs, look at Hacker News. That's what I do personally. I love Hacker News. Yeah, check out our courses.
Okay, last question. Any concurrency issue war stories?
Any concurrency issues? Yeah. We've had to raise our concurrency limits quite a few times. So you can do it. You can basically message AWS and ask to raise your concurrency limit if you're starting to hit the concurrency limits of your account. So 1,000 kind of is the default concurrency limit for an account. But you can raise that limit to something higher. And we've had it happen, and as soon as it happens, we obviously monitor our logs. We have dashboards in CloudWatch, and we monitor all errors and everything that happens. And as soon as we start seeing that, yeah, we're hitting that ceiling, we quickly get in touch with AWS and raise our concurrency limits further. We also have a look at the profile of our functions, like what is actually happening, why, is something abnormal, why are we hitting these limits? Or it could just be because we're growing, right? Because we have more students watching our content, and it's totally fine to reach those limits. So look, if you start hitting those limits, try to understand why it's happening. And if it's normal, then just, apply to raise your limit.
Great.
Yeah.
Well, thank you very much, Peter. Let's give Peter one last round of applause.